All right, here is a review for exam number 2. This is question 1. It talks about if a particle is along the x-axis from x is equal to 0 to 3 by that force, what is the work done? Okay, so work is integral x is equal to 0 to x is equal to 3 fx dx. And now substitute for fx, which is given as 4x squared plus 2x. So we have that now. And then integrate each term individually, which gives 4x cubed by 3 for the first term, and then 2x squared by 2 for the second. And then substitute the limits. And of course, when you substitute the lower limit x is equal to 0, you get 0. So just substitute the upper limit, which is what I'm doing now. So you get 3 cubed by 3 plus 3 squared by 2, which gives 12 plus 9, 21 joules. So that is how that question is worked out. The second question is about the Atwood's machine shown in the diagram, and you're asked to calculate the acceleration of the system and the tension in the string if m1 is 2 and m2 is 3. So now I'm writing the equations for both. That for the first object, the net force is T minus m1g is equal to m1a, because T is up and m1g is down. But for the second object, it's moving down, it's m2g minus T is equal to m2a. And then to solve, I add the two equations, which gets these two terms cancelled. Then you have m2g minus m1g is equal to m1a plus m2a. I'm taking g common out of these. So you have m2 minus m1, and here a is a common factor, which gives m1 plus m2. So now you get this equation when you rearrange. And all you have to do is substitute the values of the masses and g, which will give us 9.8 times 3 minus 2 by 3 plus 2, which is 9.8 times 1 by 5, which gives 1.96 meter per second squared. And having found the value of acceleration, just substitute it into one of the equations. I'm going to use this equation. So when you substitute it into this equation, substitute the value of a into that equation, you get T minus m1g is equal to m1a, from which you can find T. So that's m1a plus m1g. So when you do that, you get the tension. So m1 is 2, and then I've taken it 2 times. No, m1 is 2, correct? And acceleration is 1.96. So you get the answer as 3.92 plus 19.6, which gives the answer, which is 23.52 newtons. So that is how this problem is worked out. Now, again, the important thing in this question is to understand how to set up the equations itself. The equations itself, because you have to understand that mass m1 is moving up, right? Mass m1 is moving up. Therefore, the force of tension is bigger than m1g, so that's why we take T minus m1g. But mass m2 is moving down, so we go m2g is bigger than T, And that's why I've set it up as m2g minus t is equal to m2a. And then it's just math. So here's a question where a car is moving around a curve of radius 100 meter that is banked at an angle of 15 degrees. It's moving at the speed of 25 meter per second. And what is the minimum coefficient of friction required for the car not to skid? Now, see the forces acting are mg and n is resolved into these two components, but there's also friction acting tangential, and so you need to resolve that into f cosine theta and f sine theta. All right, take a look at the diagram, understand that. So when you do that, you find that the friction can be broken up into f cosine theta and f sine theta. So the total forces along the x-axis are n sine theta and f cosine theta, n sine theta and f cosine theta, which should give us the centripetal force, right? And then along the y-axis, you have n cosine theta minus f sine theta, which should be equal to mg. So those are the two equations. F cosine theta plus n sine theta gives the centripetal force, and then n cosine theta minus this gives mg. Now, there is a lot of steps that you have to do to bring mu into the equation and to separate it to one side. Okay, so first of all, I've substituted for friction as mu times n in that equation. And then I'm taking out n as a common factor because there's n in both terms. And then I'm going to make n the subject of that equation, which means you're going to get mv squared by r divided by sine theta plus mu cosine theta. So that is one equation, which I get from this one right here. And then I'm going to do the same thing and separate n from the second equation. So once again, friction is mu times n. So n cosine theta minus mu n sine theta is mg. Then again, take out n as a common factor. And then make n the subject as before. So you get n as mg divided by cosine theta minus mu sine theta. So that gives us equation number 2. Now, since the left-hand sides of equation 1 and 2 are the same, So once you get it in that format, now we see that we can separate mu, because mu is just going to be this whole left hand side divided by this whole term. So once you get that, plug in the values that are given, and that will help us to find the value of mu. Before that, it's easier to simplify it and divide each term here by cosine theta, so this will get cancelled. And this will become tan theta, both of these. That is just a matter of simplification. You could have just substituted into this and got the answer as well. So now you see the whole picture, the whole process that we went through. Tan of 15, so that's substituting into this, and then again you have 9.8 plus its velocity squared, which is 25 squared divided by 100 times tan of 15. Okay, when you calculate that, you get 0.32 as the coefficient of friction. So really this is a very, tedious process, but it's helpful, because what if the coefficient of friction was 0? If it was 0, then this is 0, which means the numerator's got to be 0, right? If the numerator's got to be 0, then let me show you quickly. That means v squared by r minus g tan theta is equal to 0, which means v squared by r is equal to g tan theta, or in other words, tan theta is equal to v squared by rg. So that's the formula, that's the special formula you would use, if there is no friction. So that's what you would use if there is no friction, okay? So here is another question where a soccer ball is kicked at an angle of 30 degrees above the horizontal at a speed of 10 meters per second. What is the speed of the projectile when it has reached a height of 5 meters from the point of firing? So that's point A and that's B. We are going to use energy conservation here, which means the total energy at A should be equal to the total energy at B. That means the sum of the potential energy and the kinetic energy at A should be equal to those at B. That means the sum at B. But the potential energy at A is 0, because that's where we measure the height from. And so you only have the kinetic energy at A, but at B, the ball is still moving, so it has kinetic energy, and it's at a height, so it has potential energy. So you have both. Now, actually we could cancel out the mass at this point, because mass exists in all the terms, and then substitute and calculate. This is a much easier method of doing this than using motion in 2 dimensions, as you can see. So cancel the masses out, rearrange and calculate, and you get the answer. So you have a factor 1 here on this side, and then calculations give us 1.4 meter per second. That will be the speed of the soccer ball when it is at point B. be. And we did talk about this before, and I just wanted to bring it back to show you that if there is no friction, you're just going to have the normal reaction resolved into n sine theta, which gives us the centripetal force, and n cosine theta balances the weight. So dividing one by the other gives us tan theta is equal to v squared by rg. So, which is the same exact one that we got before. So from this one, you can rearrange and find the velocity, because the question says what is the maximum safe speed, radius given, and the angle given. So we understand that the velocity or the speed at which you can go without creating a dangerous situation is going to be 5.87 meter per second. So that's how you do it. In this question, you have one mass moving horizontally on a table with friction and the other moving vertically. Okay? The masses are given as 1 and 2 kilograms. Find the acceleration and the tension. The coefficient of friction is 0.3. So here is the free body diagram. On M1, you have the normal force and its weight, and you have the tension acting. You also have the friction acting in the opposite direction, which I'm going to draw in a second. On M2, you only have tension and M2G. Now remember that the net force on M1 along the y-axis is N minus M1G, which is so N is M1G, but along the x-axis you have T and you have friction. Okay, now I've shown the friction there. So the net force is T minus F is equal to M1A. But F is mu times N, that's M1A. And N is what? N is equal to M1G, isn't it? So that's why it's mu M1G. Now when you come to mass M2, it's moving down, so M2G minus T is equal to M2A. So those are the two equations. And if you simply add these two equations, once again the tension will get cancelled if you add the left hand side, and here you will get M2G minus mu M1G. On the right side, A is common, so you will get A times M1 plus M2. And then rearrange that to get the acceleration. The acceleration is going to be this whole term divided by M1 plus M2. It's a matter of just plugging in the numbers there. M1 plus M2 is 5, so I put it as 5 there. And when you calculate, you get 4.7 meter per second squared as the acceleration. And once you get that, again, you can substitute that into this equation after taking this to the right side, which is what I'm doing. And that way we'll be able to calculate the tension. So remember that these are example problems that give you the method of actually drawing the free body diagram and then using that to solve for acceleration and tension. And here's the last one. Potential energy is given as 5x squared plus 3x cubed. What is the force acting on the system? Now you have to remember that F is the negative derivative of du with dx. So F is negative du by dx. Why? Because energy or work is integral f dx. Again, energy or work is integral f dx. So that's why f is negative du by dx. In fact, there must be there must be a negative there too. Okay. So now you just have to substitute the given value of u there, which is 5 squared plus 3x cubed. And then you know that this is 2x. So you're going to get 5 times 2, 10x. And this is 3x squared. So that is 3 times 3x squared. So which will give you 10x plus 9x squared. But the whole thing needs to be in parentheses. Okay. So that is how you calculate the force. So if you know the value of x, you can plug that in and you will be able to find the force. So this is a quick and very important review for exam 2. But remember that you have all the other problem sets to study from, and hopefully you will study from all the sources and not just focus on this review. All right, wish you all the best and thank you.